what happens? It will float or sink. Anything may happen. Okay. Take a look. If I draw one line here. So, okay, for example, this indicates the center of gravity, G. Right, G indicates here the center of gravity. Center of gravity of the object. Okay. So this point is called the center of buoyancy. This is called C.
I think that this one the impact.
This indicates the center of buoyancy. See?
It's like easy figure table.
Center of buoyancy. Center of buoyancy. This is the C. And another center is called metacenter. M indicates metacenter. Okay? So this is a common thing. Okay. Okay, I draw one line. So this indicates any object. And this object may be different shape. Okay? It may be rectangular shape, it may be cube, it may be triangular shape, or it may be circular shape. Anything, right? So I assume this is an object. So this indicates the center of gravity of this object, right? So I put here center of gravity because I put the object on water. So this is the water line. Okay? And this, I tell you, the metacenter. This metacenter can be found at any point of this line. It may be here also. It may be here also. Okay? So now you think, when I put the object here, it is tilting, right? That this direction or that direction. Correct? So when it is tilting this way, the metacenter is moving this direction, correct? Am I right?
Yes.
Yes.
Or this direction.
Yes.
Okay, when the metacenter comes below G, then it sinks. Correct? When the metacenter comes here, sink. Nobody can stop it. So now, when the metacenter is above the center of gravity, the object is stable. When the metacenter is below G, this is not stable. This is the concept. So, now the question is 20 meter long. 20 meter long is this direction, the Z direction. 20 meter long is Z direction. A 20 meter long wooden barrage has a triangular cross section. So this indicates the triangle cross section. The barrage is submerged to a depth deep in the water. So this indicates the water surface. Okay? And the barrage is submerged D meter depth in the water. Determine the value of D. In that question they tell you what is the value of D. And Z direction, the length is 20 meters. Right? This direction is 20 meters. And the gravity, specific gravity of the wood. So this is the wooden barrage. I put this one on green. This is the wooden object. And you can see the specific gravity of the wooden object is 0.65. Okay, done. So how you can calculate the value of D? How? Any idea? Of course, formula is out. know this distance. Then this angle is 30. 30. So I just draw one line from here to here. I can draw, right?
Yes.
So I can find the distance from here to here.
Yes.
Right? If I draw one line from here to here,
Yes.
the distance from here to here is 5.
Right.
Because this is a,
Tokaso.
what is this triangle? What is the name of this triangle?
Yes, correct.
Right.
This length and that length are same, right?
Yes.
This angle and that angle are same.
Yes.
So if I draw one line from here to here, so this from here to here and from here to here are same,
Yes.
right? So this is 5 meter and that portion is 8.
Thank you.
The simple geometry. Okay? I just draw one line from here to here. So from here to here is 5, from here to here is 5. We assume the distance from bottom to top, right, is h. So how you can find the value of h? You can find the value of h by tan, right? Tan 30 degree is equivalent to h by 5. Then you can calculate the value of h. Done. You can calculate, no problem. Okay. By means of calculation, state whether the barrage is stable or not. This is the important thing. How do you find? Okay? The value of h I can find, no problem. Here I can find the distance from here to here. No problem. So now, you try to understand what I do. Okay? I am going to draw, this is the understanding part. I am going to draw the triangle portion of this barrage,
This is the unknown.
right? And I just draw one line from here to here. No problem, right? I can draw. So, I know the distance from here to here, right? I know the distance from here to here, right? What is the value? I call you, this is h. From here to here, right? H. Okay, h. Now I draw the water surface. Can you tell me where should be the center of gravity? Somewhere here, right? Somewhere here. G. I put this is O. So what is the value of OG? Tell me. From the chart, right? From the chart I can find the value of from here to here is h by 3. Correct, h by 3. You can get it from the picture. Remember 5 or 6 picture? For triangular shape, this value is given OG is h by 3. Okay, so now I just draw the water surface line. This is the water surface line, right? This is the water surface. Okay, so this water surface, so the distance from here to here is D, right? In the question they tell you this is D. So center of buoyancy I can say somewhere here. Due to water, for the center of buoyancy which is C. Can you tell me what is the value of the distance from surface of the water to the buoyancy, right? C. What is the distance here? D by E. Okay? So can you tell me what is the value of OC? OC becomes, tell me,
Captain.
OC becomes the distance from here to here, right? From here to here is how much? H minus D.
H
Am I right?
minus D.
No problem. So OC becomes H minus D plus D by 3. Plus D by 3. Done. So what is the value of CG? CG becomes, tell me, CG becomes OC minus OG, correct?
OC minus copper.
From geometry, I just copy and paste. What is OC? H minus D plus D by 3. What is OG? H by 3, right? So what I can write? 2H by 3 minus 2D by 3, correct? This is CG. Then I can calculate, right? No problem. Right? H I know from the previous, H I know. So D I have to find. When I know the value of H and value of D, I can calculate CG, no problem. Right?
Right.
So CG I know. The distance from C to G I know. This distance I know, right? And the position of metacenter I do not know. Right? I tell you before, the position of metacenter may be any point of this line. Right? Any point of this line. So we assume metacenter is somewhere here, right? I put it across. This position will be shifting, not a fixed position. Right? So we assume this point is M. Okay? So how you can find the value of Cm? The value of Cm, the distance from C to M. This one you can calculate from the knowledge of total volume. This one how? How do you find this value? Take a look. Okay. What is the object? Real object is here, right? You take a look. Try to understand. Correct. Then can you see? This is a real marriage. It's looking like this. Right? My drawing is not so good. Anyway, it's something like this. Okay? Not accurately. Then this is the water surface, right? If I draw this way, this is the water surface, correct?
Yeah.
If you draw engineering drawings diagram is like this. Right? So this is the water surface. Right? Water. So this is the water, right? That is all water, correct? So what you can see? Can you see this plane? Correct? You can see this plane. And the distance from here to here is D. Right? From here to here is D.
Very good.
Correct. And the position of water is here. So what is I know? I know is with respect to this rectangle.
Previous.
And axis of rotation is this. Because it is tilting. Right? So axis of rotation is this. So I axis somewhere here. So I said this is from here to here is A, from here to here is B. Correct? Or maybe you can say from here to here is A, here to here is B. Anyone you can write. So I can say from here to here is A, right? I assume, right? Correct. But in our question, I say this is 2W. Later I show you. So this one I say from here to here distance is A. And from here to here, I say different color. So you can understand. From here to here is B. Right? B. So what is I naught? 1/12 B A Q. This is B, right? A Q. What is the volume? Tell me. Volume of displaced. Okay? So So this volume I can write triangle, right? Area of the triangle 1/2
Ah,
A
easy.
B, right? Distance from here to here is B.
Ah,
Eh?
B times from here to here is B. Alright? Then you can find the distance CM from here to here. Now you compare which one is bigger, CM or CG. Correct? If CM is bigger than CG, the object is stable. Right? Or I can write if Cn minus Cg is positive number, right? Any positive number. The system is stable. System is stable. Alright? Secondly, if
left to right.
Cm minus Cg is any negative value, so the system is not stable, right? Understand? Understand or not? You have to find the distance from here to here and distance from here to here. Nothing new. From here to here you can find from this calculation. And from here to here you have to use this equation. Alright? And because it is moving this way, so this is the axis of rotation. So that's why I can write BAQ. And this is B. The distance from here to here is B. This is B. This is from here to here is A. From here to here is D. Then I can write 1/12 BAQ. What is the area? Area of a triangle, half times A times D. Volume, the distance from here to here. That's all. Alright? Any question? Then you have to find the distance CG and CM. Then after that you have to compare. If CM is greater than CG, it's stable. If CM is smaller than CG, it's not stable. This is the understanding. Alright. So I'm going to show you the solution. Same thing. You take a look. So from here to here is 10 meter. From here to here is D. From here to here is H. Right? From here to here is here is 5, here is 5, right? So here is 10. So the distance in Z direction is 20. From here to here is 20. We assume, take a look. This one we say W. This one we say W, right? The distance from here to here is 2W. That means here to here is 2W. 2W in my previous equation I say 2W is equivalent to A, correct? And B is equivalent to 20 meter. Alright? Right, and D you have to find. Now the question is how? Now the distance here from here to here is 5, here to here is 5, so 10, 30 is H by 5, and H is 5, 10, 30, I can find this number. Okay, so what is 10, 30 again? So this is also 10, 30, similar triangle, this is also 30. So I can write 10, 30 is from here to here is W, right? And from here to here D, correct? So D by W. So W becomes D by 1030. Then I can write 1.732 times D. This indicates the value of W. Alright. Then can you tell me, is there any other concept? I have one equation only, right? H I know, but W and D. It's tough, right? How to find? So when I calculate W, I see, oh, W is a function of D, right? Then I have to find the value of W. Then I can find the value of D. Just substitute the value here. So now, where is the another concept? Right? What is Archimedes' law?
The volume equal to the
Volume of displaced water is equivalent to, not displaced water, maybe any fluid, is equivalent to
weight.
the weight of the object. Correct?
Yes.
Yes. So now, where is the object? Tell me in that question. The object is the barrage. The object is the barrage, right? I just put the red color. This is the barrage.
You don't know.
Right, this is the barrage. And of course, you have to consider the 20 length. Right? Then what is the weight of the barrage, right? Weight of the barrage is equivalent to the weight of displaced water. Correct? So, weight of barrage I can calculate here, right? What is the weight of barrage? Tell me. So, density of barrage times the volume of the barrage. Correct, this is the mass of the barrage. Done. Then, this is the mass of the barrage is equivalent to density of barrage and the volume of barrage. So, can you tell me what is the density of the barrage? Specific gravity of the barrage, right? Which is 0.65, right? Very good. So, I can write 0.65 times density of water, correct? Times what is the barrage volume? The triangle, right? So, what is the triangle? Tell me. Times this one times half times 20, right? From here to here is 20. 10, right? Not 20, 10. Half times 10 times h, correct? H. Right? So h I know, which is 2.8868, right? 2.8868, right? 8868. Times length, right? 20. Very good. Then I can calculate the weight of the this is the weight of the barrage, the red portion. And so what is the density? So sorry, what is the displaced water? So water position is here, right? Am I right? This is the water position. And here is the water position, correct? So what is the weight of displaced water? Mass of displaced water is equivalent to rho of water, right? Times volume of displaced water. Then I can write rho of water times, what is the displaced water volume? Half, right? Times D times 2W, correct? Times 20. Am I right? Right. So this equation is equivalent to this number, correct? So by Archimedes law. Then I can find another relationship between D and W, and here is another relationship D and W. Then I can calculate D and W. Two equations to one. Alright? Understand? Good. Now I can go to the next slide. In next slide I show you the calculation. Right? I can write rho of water, this is the volume of water displaced, rho of barrage, G, volume of barrage, right? Then I can write rho of water times G, this one you cancel. Rho of water times G, half times 2W times D, 20, right? 0.65, rho of water, G, correct? Times half, right? Half times 10 times h times 20.
배우 그냥 알았어요.
So, same thing, I show you. Now I can cancel, right? This one cancel, half cancel, right? 20 cancel. Then after that I can get another relationship. So you can take the picture if you wish.
Subscribe.
Okay? Now I go to the next slide. This is enough. Okay. Then I can find W times D, 0.65 times 5 times H. Then I substitute the value of W, which is 1.734 D, and D is there. 0.65, I can take it here, right? So D is 2.236 meter. So W becomes, from the previous equation, I can find 1.7321 times D. I substitute the value of D here, I can get 4.03 meter. So 2W is 8.06, which is A. You remember, right? In the previous slide, I show you A. So then volume of displaced water is equivalent to this number. All right. Just substitute the value. For understanding, I'll show you. May I go next slide?
Okay.
You have to practice, okay? So now this one I explained you already. So now you can see OG or CG. I can find OC minus OG. I substitute the value. This one, and I get CG is equivalent to 0.3729. Value of CG. Okay? So what is the value of CM? CM you have to find from this relationship. CM from here to here, right? I show you. The axis of rotation is here, right? Somewhere here. So from here to here, the value is A. And from here to here is B. From here to here is D, you know. And I can find CM 1 I naught by B. This is the volume of displaced water. Okay, so I naught 1 over 12 BAQ. I tell you before, and this indicates the displaced water volume. In CM I can get 4.6. So which one is higher? CM is higher, right? What is CG? Smaller, right? 2 point something, if I am correct. So CM becomes 4.65, which is much higher than CG. So the system is stable. So if I get this value is very small, then not stable. Correct?
Yes.
Okay? So now you understand the system is stable. I show here GM, CM minus CG, this is positive number. So meta center is above the center of gravity, so very stable. So the concept is this one. When generally, I show you before, this is C, this is G, this is M, right? When it is tilting this direction, you can see, this indicates the center of gravity, right? But this position, right, this whole position changes this way. That means it is coming this direction. This is center of, what is the center of buoyancy? This is the meta center. It is coming here. Still now, M is above G. So it is more tilting, you can see. N is below G. So this portion is not stable. Alright? Okay, this question is related to pressure. In this question, an open rectangular tank. So this indicates an open rectangular tank. The tank is 1 meter width. Right? So 1 meter width is this direction is 1 meter. If the tank height is 1 meter, if the height of the tank sides is 1.5 meter. That means from here to here is 1.5, from here to here is 1.5. What is the maximum horizontal acceleration? And from here to here is 2 meter, okay? Here is 2 meter long, and this direction is 1 meter, okay? That direction. So now the question is, take a look, the question is what is the maximum horizontal acceleration that can be developed before the gasoline would begin to speed? This is the question. What do you understand from here? What is the maximum horizontal acceleration along the longitudinal axis that can develop before the gasoline would begin to speed? That means the tank is like this, right? If I move it this direction, what happens? Push this direction, what happens? Acceleration is y direction. Here I say, here is z direction. So this way y, and that way is x, according to the textbook. Okay? Otherwise you will be confused. I don't change the axis. So acceleration I push this way. So that means acceleration is that way, correct? So now I push this way. So acceleration is that way, correct? So as I push this way, so water this direction, right? Because water, this level will moving upward, right? And that level will moving downward. Correct? So they tell you what is the maximum horizontal acceleration? What is the maximum level of fluid? What should be the maximum level? Okay, I push slowly. It may come here. Right? This is not the maximum, correct? Slightly more it is coming here. Slightly more it is coming here, right? More it is coming here. So this should be the maximum number, right? When the water level reach the top or tip of the tank or height, then you can find the maximum acceleration. Otherwise, if you further push, then water will scream. This is the question. Okay, so now, when the system is stable, you can see there is also acceleration, right, at the z-axis due to gravity. So at x, you see, in the z-axis there is an acceleration due to gravity. In that axis, there may be acceleration, and z-axis also there may be acceleration, right? All right. If I push this direction, acceleration is y direction. If I push this direction, it's x direction, right? If I push from the top, of course in the z direction. All right? But g, acceleration due to gravity, is always present in the z direction. Must be there, okay? Okay, now what I can write here? When I push, I apply some force, right? That means pressure also change. Same thing. There is force, there is pressure. So what I can see? This line, right? When I see this line, that means the level of water doesn't change, right? That means the pressure looks like constant here. Doesn't change. That means the change of pressure at that line is constant. Right? So we can say change in pressure is same. 0, right? So what is the total pressure change?
0.
Tell me. I can say pressure is a function of both directions, right? X, Y, Z, right?
Yes.
What is the change in total pressure? Change in total pressure, I can say dP is equivalent to delta P by delta X dx. Delta P by delta Y dy. Delta P by delta Z dz, right? That means some pressure change in X direction, but in both Y and Z direction, these values are constant. That means this value is changed in X direction, but this value is constant in both X and Y, Z and Y. This value is constant, Z and Y. Only X direction is changed. Similarly, this number is changed only Y direction, but X and Z are fixed, doesn't change, constant. Similarly, dP by dz, X and Y are constant, but it change along Z direction. This is the understanding. Okay? So from Newton's law of motion, you know F equals to ma, right? From that concept, I can write delta P by delta X minus rho acceleration in X direction. Similarly, delta P by delta Z, I can write minus rho G plus AZ, right? Acceleration due to gravity along Z axis. That's why G is present. So in the Y direction, I can write delta P by delta Y minus rho AY. Now you have to find the value of this for this question. Alright? So now I show you the theory from your textbook. I can keep it. Delta P by delta X rho AX, delta P by delta Y minus rho AY, delta P by delta Z minus rho C plus AZ. And this is the total derivative. Delta P by delta X, all these are same, right? Okay. So now what I can write? Tell me. I show you the equation first. Delta P by delta dP minus rho AX, right? dx, correct? Minus rho AY dy minus rho AZ plus Z, correct? Am I right? I substitute the value only. So, but change in pressure is 0, right? Because these lines are constant. Because this line are constant. Okay, constant this line. That's why this guy is 0. So, can you tell me, is there any acceleration in the x-axis? X is this direction. No, right? In this question, there is no acceleration in the x-axis. No. 0. This is 0, right? In acceleration in z-axis, this is also 0. Nothing. Only there is acceleration in y-axis is present. So I can write, can I write this? 0 becomes minus rho AY dy minus rho G dz. Correct. Then in the question, this is z direction, and that one is y direction, right? X direction, no, nothing. Now I have to find AY. So what I can do? I can say rho cancel, right? I can write AY dy is equivalent to minus G dz. Am I right? So I can write AY becomes minus G times dz by dy. Done. This is the answer. But you have to find the value of dz by dy. What is dz by dy? This indicates the gradient of this line, right? I can find the gradient along y and z direction, right? So this is the gradient, right? Gradient is the slope. dz by dy is the slope of this line. Slope is equivalent to dz, right, by dy. Correct. So can you tell me what is the slope dz by dy? Tell me. dz by dy. Can you tell me slope?
1.5
The distance from here to here. Correct. Right. 1.5 minus 1.0. Correct. By the distance from here to here. Total is 2, right? Here is definitely 1, half. They tell me from here to here the distance is 2 meter, definitely 1 meter. Done. So the slope is positive or negative? Negative. It's going down. So the slope should be negative. So I should put here a negative number. Okay? So the value is minus 0.5. So minus 9.81 or 8 times minus 0.5 is the answer. Okay? Meter per second square. Done. Understand? This is the way you can solve. Start from the basic. If you start from here, somebody start from here. You don't understand. What happens? Alright? So now I show you the solution. This is the solution. You can take a picture if you want. What is the reason? Line of constant pressure is 0. dz by dy, ay z plus az. So this one is cancelled. Then I can find same thing, dz by dy minus 0.5, dz by dy this one, ay is this value, a max this number, y. Answer is 4.91 meter per second. Okay? You understand or not?
Problem?
Okay, this type of question is coming in the exam. Just understanding is important. Sometimes in the question they tell you to find the pressure. What to do?
That's easy.
Sometimes they tell you find the pressure. They tell you the pressure is not constant. What is the pressure at that point? Correct. They can tell you. Then in that case, what you do? You remember this equation? dt becomes minus rho ay minus rho. Correct. Az plus z. You remember, right? So this one is dy minus this one is dz. Then you have to do integration. 0 to some number p or p1 to p2. Right? Minus rho ay dy rho az plus z dz, something like this, right? Then you have to integrate to the left hand side and right hand side. Then you can find the equation. If delta p is not 0, right? If delta p is not 0 or p is not constant. P is constant means p1 and p2 are same, right? After integration you can find 0. Alright. So this is the last question. This question also the same thing. U-tube contains mercury and rotates about of center axis AA. At rest, the depth of mercury in each leg is 150 millimeters. The distance from here to here is 150 millimeters. Determine the angular velocity for which the difference in height between the two legs is 75 mm. They tell you have to find the angular velocity. That means I rotate this, right? I rotate in this direction. Last time it was
One direction.
linear motion. Now is angular motion. That means angular velocity is omega. Right? And from here to here is, I assume, in radial direction. Moving in radial direction, right?
Yes.
So I can tell you the pressure difference between this leg and that leg is 75 mm. This is the question. Done. You have to find the value of omega. Done. So in that case, I can say the pressure is a function of R direction, Y direction, Z direction, X direction. Done. And also some angle, right? When it is moving, it creates one angle. Right? Angle. So now you can see, right? It is a function of R direction, Z direction, and angle theta direction. And XY we remove for simplicity. Right? Then I can write delta P by delta R. You see, delta P by delta R dr, delta P by delta theta d theta, delta P by delta Z is Z. In the Z direction, acceleration is AZ, and this one is present. Wait.
Yeah.
And R direction minus rho AR is equivalent to rho R omega square. AR, this one indicates minus R omega square. So rho R omega square. And this one we consider 0. Alright? Then this one is 0. This one and that one is present. And delta P here is 0. Okay, now you can take a look. Delta P by delta R, dr, delta P by delta theta, d theta, delta P by delta Z, dz. Right? I substitute the value. I get this equation. Remember, for this case, we assume this point is A and this point is B. Okay?
Yes.
And the height, okay, after acceleration, this point goes down up to here and this is moving up to here. This is the new position. So this indicates the new position of the fluid. Right? And the height difference is delta H, which is given, right? 75 mm is given. So now, what I do? This one we consider 0. Delta P is 0 because of constant pressure line. So now I can tell you this one also 0, right? I can say after that, so this one also 0. There is no acceleration in Z direction, 0. So G is present and this is present, right? Then I can write R omega square dr, Z, Z, dz, right? Then I can find this equation. Then what I do here? Then can I write this way? Omega square G integration R dr dz. Correct?
Yes.
Then R, from here to here is, I say RB, here is RA. Then I can write RB, here is RA. And here is ZA, correct? And here is ZB, in Z direction. Then I can say, after integration I can write, and take a look, omega square G. After integration I can find R square by 2, right? Then I can say RA square minus RB square by 2 is equivalent to ZA minus ZB. ZA minus ZB is equivalent to this distance, delta H, which is 75 mm. So in that question, what is the value of RA? Tell me. RA is 220 millimeter, right?
2, 2.
Correct. This one 0.22 meter. You have to convert. RB 90 millimeter. 0.09 meter. And delta H 75 mm. It's given.
Given.
0.075 meter. So delta H is given. Delta H 75 mm. 0.075 meter. Then after that, you substitute all the value here, and finally you get the value of omega. I show you here. You can find the value of omega here. Then this one I show you already. Nothing to show. Alright? This question are easy, but exam not easy. Okay? You have to practice more. First year question, especially. Just get some idea. But not 100% accurate, okay? We change every year question. Not 100% accurate. Cannot.
I cannot. Can.
Impossible.
You can.
I change every year. Okay.
Change number. Oh, some cover. I don't know I'm saying that. Subscribe to